Hello class. In this video I would like to make some comments about chapter number 17. Chapter number 17 is the first one of module number 3. Module number 3 is about the air quality. So what are the mechanisms that we have in the planet that defines or triggers effects over the quality of the earth that we have, and also what are the mechanisms that ourselves triggers into the earth that affect the quality of the earth. So this is basically chapter number 17, module number 3, okay? And at the end of module number 3, we're going to talk about chapter number 19, which is fossil fuel. Fossil fuel is something that have to do nothing directly with the air quality, but because of the burning of the fossil fuel energy, we are going to expel some greenhouse gases into the atmospheres, and thus, of course, is going to have an adverse effect into the quality of the earth. But in this particular chapter 17, and as you review already, the main subject is to understand the atmospheres and how the atmospheres defines conditions over the weather and the climate. Okay, so I think that I'm going to start by showing this slide. It might be this one in here. Okay, and let me bring this part. So as you know, we have 4 layers for the atmosphere. What is the atmosphere? The atmosphere is the layer that is over the surface, are gases in that layer, okay, that it is called as the shield of the planet. Okay, so not all the planets in the solar system have atmospheres, but those ones that have the bless from God of getting atmospheres, those planets are subject to some kind of conditions that are going to benefit the preservation of the life in the planet. And of course, when I say that, is basically to the Earth, because as far as I know, there is no life in other planets, at least in the solar system, right? But we have 4 layers within the atmosphere. The one that is far away, really close to the outer space, is what is called the thermosphere. Then we have the mesosphere, okay, and then the stratosphere and the troposphere. Each one of these layers, they have a particular role. For instance, let me mention this one, the mesosphere. The mesosphere is responsible to protect the planet or the Earth from any object that is coming from the outer space. Okay? So, for instance, the meteors, okay, or some other objects, when they are hitting into the planet, the temperature profile in here increase as they are getting into this layer, and of course that increment of the temperature gradient will destroy the object that is getting into there. So that's what we have. For instance, the meteors, when they hit into the Earth, okay, most of them are going to be destroyed within the mesosphere. That's why we say that it's a shield for our planet. Some of them, as we know, they're gonna impact into the planet I mean the largest one, but when they impact into the planet, really the size of that meteor is going to be lower than the original size. Okay, so that is the specific role of the mesosphere. Then we have the stratosphere. The stratosphere is a filter layer. So in the stratosphere, I'm sorry guys, in the stratosphere, what we're going to have is that we have the ozone layer, and the ozone layer is responsible to trap all that radiation from the sun that is really adverse for the health of the people, for our skin. That's correct. So that's why it is very important for us to preserve this ozone layer. Okay, and then the lowest one, which is the closest one to the Earth, is what is called the troposphere. And the troposphere is very important because it's the one that have the more concentration of oxygen. So that's why we are able to breathe, okay, in the planet. But also the troposphere is also very important because they have the function, or this layer have the function to trap the energy that is coming from the sun to create an effect that is called the greenhouse effect. So this composition of the atmosphere really triggers conditions about the weather and the climate that we have in the Earth. Okay, so we are really blessed to have the atmosphere. For instance, if you compare the Earth with Mercury, Mercury is the planet that is really closest to the sun. Okay, we might think that in Mercury the temperature during the day is so high, and actually it's very high. It's about 800 Fahrenheit degrees. But during the night, the temperature drops below the freezing temperature here in the Earth. It's almost minus 300 Fahrenheit degrees during the night. And what is the reason for that? Because Mercury really doesn't have an atmosphere. So all the energy that is coming from the sun during the day is sending back to the outer space because they don't have any shield to protect and to grab energy to keep the Mercury in a temperature that is going to be a good temperature for the life condition over there. That's why in Mercury it is impossible to have any type of development of life. Okay, so the most important part is in this chapter, or one of the most important part within this chapter, is to understand that we have a big layer over the surface of the planet, of the Earth, that is a shield, but also a filter that is going to trigger, or is going also to regulate the weather and the climate within the planet. Okay, that is one thing that I want to mention in here. The other thing has to do with the shape of the Earth. And let me go over there. Because the shape of the Earth is like an sphere, so really the amount of energy that is impinging over the Earth is not the same all over the world. So very close to the poles, the energy that is trapped, really the density of energy or radiation that is coming from the sun is lower compared with the energy that we are able to receive in the equator. So that means that close to the poles, okay, we are expecting to have lower temperature compared with the ones that are close to the equator. Okay, so the density, the amount of radiation for given unit area, mile square square miles, square feet, or square kilometers, whatever unit area you want to think about it, okay, the amount of radiation coming from the sun in that particular unit area is going to be lower at the poles compared with the ones in the equator. And this have to do with the shape of the planet. But there is also another characteristic in the Earth that define the distribution of energy during the year all over the planet. And that have to do with the fact that really the planet is tilted. Okay? So the main axis of the planet is not vertical. It's tilted around 23 degrees because there is a magnetic field that is controlling the direction of the axis of our planet. And actually the polarity of the magnetic field change in geological time, but that is not the objective of this course. But the most important thing is that really the Earth is tilted, and the reason that the Earth is tilted is going to define, okay, the pattern of distribution of light or radiation coming from the sun in our planet during different moments in the year. And because of that, we have 4 stations. We have 2 stations, two seasons. That stations is coming from the Spanish, guys. I'm so sorry. Okay, we have 2 seasons in which the amount of energy is all about the same between the North Hemisphere and the Southern Hemisphere. But we have any other seasons, okay, that is called solstice, in which the amount of energy over the Northern Hemisphere is going to be different from the amount of energy coming from the sun in the Southern Hemisphere. And that has to do with the fact that the Earth is tilted about 23 degrees. What happened during the solstice, either summer or winter? What is happening is that the poles, the northern poles and the southern poles, during that period of time, they're gonna be totally shine or they're gonna be totally dark. Okay? During summer, okay, the Arctic is going to exceed completely days of about 24 hours. Okay? When the Earth is going to rotate, all this part is going to receive radiation from the sun. However, in the Antarctic, it's going to be night during the whole day. And vice versa during the winter here in the northern part. In the northern part, okay, during winter, around December, November and December, the Arctic is going to be dark during the whole day, and the Antarctic is going to be day during the 23 or 24 hours. So that means that in December, in winter, we have more radiation in the southern part and less radiation in the northern part. And it's going to be exactly the reverse when we have the other solstice that is going to be in summer. Okay, so that is very important. And these two facts together, the tilted characteristic of the Earth planet, okay, and also the presence of the atmosphere is going to define the different patterns of the weather and the climate. Okay, And that is the most important thing that we need to remember from this chapter. Now, what is going to happen in the hypothetical situation that we don't have any inclination of the axis of the planet? Well, that the planet is not going to show any type of seasons. So during the whole year, okay, the planet during the whole year is going to observe everything all over the world. Okay, so that is something that I want to mention in here. So this will create some conditions over the planet, okay, that is going to be related with areas in which we're gonna moisture, okay, most of the radiation that we receive from the sun, and in other parts we are going to evaporate most of the radiation, creating this type of loop that is called convective loops. This type of behavior is what creates natural phenomena that is called the Niño phenomenon, for instance. Okay? El Niño is something that is very important because that means that every 2 years in California we're going to have conditions in which the state of California and the northern states in the western part of America, they're going to receive evaporation and they're going to be able to receive water coming from the atmosphere. I mean, it's going to be rainy seasons, and that's what is called the El Niño phenomenon. Okay, that's what is showing in here. Let me see if I can capture that. This is the El Niño phenomenon. Okay, when we don't have disruption of this convection cycle, which is this sketch that we have over here, then we are sending warmer air from America to Asia. And that's why we have a lot of flooding, okay, here in this part of Asia. So it's a lot of rainy season over there, okay? And that is going to be favor for the ecosystem here in front of the coast of Chile, because all these waters are going to be very cold waters, okay? So most of these nutrients that are coming from the deeper part of the oceans are going to feed the ecosystem that we have in here. That's why during those time in Chile, and one part in Chile, Bolivia, and so on, they have a very good season for the fishing industry. Okay? And this is the reason for that is this one. When this loop is interrupted, is disrupted every 2 years in general, that creates what is called the El Niño phenomenon. Okay? So that is going to break this loop, but with the benefit that now part of this warm air will be transferred into the western core of America. And then the dry season that are very long in California is going to be reversed to produce a lot of rain over there, a lot of rainfalls. So you can see how these conditions that are defined because of the shape of the air and also the atmosphere, together with the winds that we have in the planet, creates or trigger conditions about the climate and weather in the earth. Let me see here if I can find something about those winds conditions. Those are the ones that you review. I'm not going to go in detail from there, okay? But the winds conditions that we have create zones in the earth that define why in the earth we have different type of ecosystems. So, for instance, in here, this part over here, in these latitudes, okay, really close to the 30 degrees, and to the south, we have deserts, okay, like the Sahara Desert in Saudi Arabia, okay, desert, I'm sorry, desert, I'm sorry guys, desert, okay, and in here, for instance, in England, okay, we have a lot of evaporation, okay. This evaporation sometimes creates some troubles in the western part of Europe. But the most important thing of the evaporation is that in the winter, okay, those northern countries are going to have some reserve to absorb warming air that is coming from America. And those warming airs are transferred to America because of this pattern of winds that are called the western lights. Okay, and let me make another comment here. Okay, so all these type of things that are controlling the climate, the pattern of the climate, are things that have to do with conditions of the earth, are because of natural conditions of the earth. Okay, that is very important to keep in mind. Okay, sometimes we have something that is called inversions because of the presence of mountains. Okay, so that is going to create an inversion of temperature within the atmosphere. Okay, in which now cool air is going to be close to the surface and warm air is going to be over some layer in the surface. So that reverses the natural behavior of the temperature. Okay? That inversion creates conditions in which we trap in this sublayer a lot of greenhouse effect and then create some typical disruption in the climate. That's what happened in England in those days of our primate or the Prime Minister Winston Churchill. I think that we have that comment over here somewhere. I don't remember very well when we have that one. Let me see if I can find it. Is this one over here. Okay, so that's what happened in 1952 that took a very high toll of life in London. Okay, I hope that you guys were able to review this this part. Okay, so those are the kind of things that we need to keep in mind. Sometimes most of these phenomena have to do with natural conditions, okay? But some other times the man is responsible to expel a lot of energy that is going to be trapped into the atmosphere and is going to trigger the greenhouse effect in the planet, okay? Inducing an increment of the temperature during in our planet. That's part of the problem. And when you trigger those kind of things, okay, those gases, because we start consuming a lot of fossil fuel energy, okay, what we are doing is sending into the atmosphere all these gases, okay? And the problem is that some of them, they last in the atmosphere for hundreds of years. When they last within the atmosphere for hundreds of years, that is going to create a disruption in the pattern of the climate. And this is the kind of things that we need to understand from this module. Okay? The greenhouse effect is a mechanism in the earth that is very important. It's a good mechanism because in somehow that is going to guarantee that the temperature will be in the earth will be reasonable to sustain the life. The only thing that we don't want to have is just to increase in a disruptive way the greenhouse effect. If we increase substantially the greenhouse effect, then that is going to create a disruption in the climate and is going to trigger the temperature in the earth. And that is going to create, of course, a problem in our life and in our resources. That's the comment. Because many of these greenhouse gases, like the CO2, okay, they last in the atmosphere for many years. So anytime that we expel equivalent unit of CO2 to the atmosphere, okay, that unit will be within the atmosphere for tens and hundreds of years, disrupting our climate. Okay, so that is something that, guys, you need to keep in mind. Some of the phenomena are natural, some other phenomena are triggered because the activities of the humans in the earth. Okay, thank you.